Okay, question 10 in the June 23 Edexcel paper 1. This is to do with a circle equation. So we've got this circle equation given to us here where k is a constant. We need to find in terms of k the coordinates of the center of C and the radius of C. So first of all, we need to think about what a circle equation looks like. It will always look in this format where you've got x minus a, some value a squared, plus y minus some value b squared equals r squared. So what this tells us then, our center will be the negative value. So instead of minus a, it will be a and b. So that will be our center, and our radius r. So knowing that, I need to somehow convert this into this format. And it's not as difficult as it sounds, just involves a bit of completing the square. So first of all, if you group the x's and the y's together, so I'm going to rewrite this equation as x squared plus 6kx plus y squared minus 2ky. And we've got plus 7 on this side, which I'm going to subtract 7 from both sides. That gives us minus 7. Okay, so from here, this first bit, I want to complete the square. So just on the x part, if I complete the square there, that will give me a bracket with x minus something squared or plus something squared. And I can use that in order to work out what my center is. So if I complete the square on that, remember we need to half the coefficient of x. So it becomes x plus 3k squared. But if I was to expand this out, I'd also still have plus 9k squared when I expanded it, so I need to subtract that in order to complete the square. Do the same thing for your y value. So here I want to do y minus 1k all squared, so y minus 1k squared, and again to complete the square I need to subtract this value k squared. Just completing my formula around it, it's going to be that plus that equals minus 7. Just neatening this up a bit, if I rewrite my equation now, I've got x plus 3k squared plus y minus k squared, and minus 9k squared minus another k squared gives us minus 10. So if I add 10k squared to both sides, I end up with equals 10k squared. We already have the minus 7, and because k is a constant, that means that value there is a constant. The values inside there are a constant, so therefore I can work out my center will be the negative values of what's in the brackets. So in this case it will be minus 3k, my x value, and plus k for my y value. So that would be my center. My radius, and a common mistake here, people forget to do the square root part, because don't forget this tells us what r squared is 10k squared minus 7, so r, the radius, will be the square root of 10k squared minus 7. And that completes part A, parts 1 and 2. Now for the next part we need to work out, it says the line with equation y equals 2x minus 1 intersects C at 2 distinct points. We need to find the range of possible values of k. Okay, now just to kind of illustrate visually what we're going to be doing here. At the moment we've got a circle equation and the line y equals 2x minus 1, and it tells us that it intersects at 2 distinct points. So when you sub this value into this equation, so we're going to get rid of y, so I'm going to sub that into this equation, and what you're going to end up with is some sort of quadratic. And because it intersects at 2 distinct points, this should be a major clue for you. It tells you then that your discriminant b squared minus 4ac, that has to be greater than 0. If it was less than 0, the line wouldn't touch the circle at all. And if it touches only just once, then b squared minus 4ac would be equal to 0. So using our understanding of the discriminant, we can then work this out. So let's do our subbing in first. So I want to sub in y equals 2x minus 1. So x squared plus 2x minus 1 squared plus 6kx minus 2k times y, so times 2x minus 1 plus 7 equals 0. Let's expand, simplify and neaten this up a little bit. So that gives me x squared, that'll be 4x squared minus 2x gives me minus 4x plus 1 plus 6kx, and then expanding this bracket, that gives me minus 4kx plus 2k, minus times a minus, and I've got plus 7 equals 0. So again, let's neaten this up. X squared plus 4x squared gives me 5x squared. Now, in terms of my coefficients of x, I've got minus 4, 6k, and minus 4k. So if we combine those, I've got, so minus 4k plus 6k gives me 2kx, so 2k, and I've got a minus 4. So those will be my coefficients for x. And that's important to be able to factorize that out there. What else do we have? We have 1 plus 7, so 8. So I'm left with plus 2k plus 8. And because k is a constant, that means this value here is a constant. This value here would be a constant. So now I've got enough information there to work out my discriminant. So here a is 5, b is 2k minus 4, and my c, my constant value, will be 2k plus 8. So using those values, if I substitute those into b squared minus 4ac, that will be 2k minus 4 squared minus 4 times a, so times 5, times c, which is 2k plus 8. And that's got to be greater than 0. So expanding this out, that gives me 4k squared minus 8, so minus 16k, and then plus 16. And this will give me minus 20 times 2, so minus 40k, and minus 20 times 8, so minus 160 is greater than 0. Again, just neatening that up leaves me with 4k squared minus 56k, and then 16 minus 160 gives us minus 144. So now we've got it in the format of a quadratic, so we can use this to work out our values of k. First of all, if we divide through by 4, that gives us k squared minus 14k minus 36 is greater than 0. And what we want to do here is use our solve function on the calculator. So let's work out the roots of this quadratic here are 7 plus root 85 and 7 minus root 85. So when is this equation, when is k greater than 0? If you do a little sketch, which I always advise you to do when you're solving inequalities, in this case here we've got two roots, 7 minus root 85, 7 plus root 85. And that's a quadratic that goes through there like that. So when is this quadratic greater than 0? You can clearly see from the diagram any x value below 7 minus root 85 is greater than 0. So therefore k must be less than 7 minus root 85. And equally on the other side, anything that's a x value greater than, or k value in this case, 7 plus root 85, all of these values will be above 0. So therefore k must be greater than 7 minus root 85. And we found the possible values of k.